The National Electrical Code, or NEC, mandates ground fault circuit interrupter, or GFCI, protection for all receptacle outlets situated in damp or wet locations, which includes bathrooms and powder rooms. This requirement extends to outlets that supply small appliances. The NEC does not contain a direct prohibition against having multiple GFCI outlets on the same circuit. However, the code stipulates that each GFCI outlet must provide protection for its own downstream outlets. This means that the GFCI installed in a powder room should not extend its protection to the GFCI located in an adjacent wet bar. While it might seem like overkill to dedicate a separate circuit to each GFCI outlet, doing so can enhance both safety and operational flexibility. For instance, if the GFCI in the powder room trips, the interruption will be isolated to the outlets within that specific room, leaving the wet bar outlets unaffected. Based on NEC guidelines, safety considerations, and the desire for enhanced flexibility, it is generally advisable to install separate circuits for each GFCI outlet in areas prone to moisture or dampness. Firstly, the NEC, specifically Section 210.11 C3 addresses bathroom circuits. This section mandates that at least one 20-amp branch circuit serve the bathroom receptacle outlet or outlets. Such circuit should have no other outlets. Secondly, the exception to this rule is that a single 20-amp circuit can supply bathroom receptacle outlets and serve only the bathroom of dwelling units. This exception clarifies that you can have multiple receptacle outlets within the same bathroom on a single 20-amp circuit, but it cannot serve other areas. Thirdly, NEC Section 210.8 details the requirements for GFCI protection. This section requires GFCI protection for receptacles in bathrooms. Fourthly, in the context of a wet bar adjacent to a bathroom, the NEC generally considers a wet bar as a separate area. Therefore, it should ideally have its own dedicated circuit, especially if it includes a receptacle. Fifthly, it is essential to understand the intent behind these requirements, which is to minimize the risk of electrical shock in areas where water is present. Having separate circuits for bathrooms and wet bars reduces the likelihood of nuisance tripping affecting multiple areas and enhances overall safety. Sixthly, the NEC is not always prescriptive but rather provides a baseline for safe electrical installations. Local codes and interpretations can vary, so consulting with a qualified electrician or local building inspector is always recommended. Seventhly, using a 20-amp circuit allows for a greater load capacity, which can be beneficial if multiple appliances are used simultaneously. This reduces the risk of overloading the circuit and causing a breaker to trip. Eighthly, when wiring GFCI outlets, ensure that they are correctly installed following the manufacturer's instructions. Incorrect wiring can lead to malfunctioning GFCI protection, defeating its purpose. Ninthly, consider the long-term benefits of running separate circuits. It may initially seem like more work and expense, but it provides greater safety, convenience, and potentially increases the value of the property. Tenthly, be aware that the NEC is updated regularly, typically every 3 years. It is crucial to stay informed about the latest changes and requirements to ensure compliance with current standards. When deciding whether to use one or separate circuits for GFCI outlets, several factors come into play. Firstly, the NEC requires GFCI protection in damp or wet locations such as bathrooms and wet bars. Secondly, while the NEC does not explicitly prohibit multiple GFCI outlets on the same circuit, it emphasizes that each GFCI should protect its own downstream outlets. Thirdly, running a separate circuit for each GFCI outlet enhances safety by isolating potential trippy issues. Fourthly, a dedicated circuit for each GFCI ensures that a fault in one area does not affect the electrical supply in another area. Fifthly, the NEC Section 210.11 C3 requires at least one 20-amp branch circuit for bathroom receptacle outlets, with exceptions for serving only the bathroom. Sixthly, wet bars adjacent to bathrooms are generally considered separate areas, necessitating their own dedicated circuits. Seventhly, the intention behind the NEC requirement is to minimize electrical shock risks in areas with water presence. Eighthly, local codes and interpretations may vary, necessitating consultation with a qualified electrician or local building inspector. Ninthly, using a 20 amp circuit provides a greater load capacity, reducing the risk of overloading the circuit. Tenthly, proper wiring of GFCI outlets is crucial for ensuring their effective protection. Consider these points when planning your electrical installations to ensure compliance and safety. When addressing the installation of ground fault circuit interrupter, or GFCI, outlets in bathrooms and adjacent wet bar areas, it is essential to understand the underlying principles and the practical implications of the National Electrical Code, or NEC, requirements. Firstly, the primary purpose of a GFCI outlet is to protect individuals from electrical shock in areas where water is present. This protection is achieved by monitoring the current flowing in a circuit and quickly interrupting the power supply if a ground fault is detected. Secondly, the NEC mandates GFCI protection in all damp or wet locations, including bathrooms, powder rooms, and areas with sinks such as wet bars. This is because the presence of water significantly increases the risk of electrical shock. Thirdly, NEC Section 210.8 specifically outlines the locations where GFCI protection is required. It is important to review this section to ensure compliance with the code. Fourthly, while the NEC permits multiple outlets on a single circuit, it also imposes limitations to ensure safety and prevent overloading. For bathroom circuits, NEC Section 210.11 C3 requires at least one 20 amp branch circuit to serve the receptacle outlets. Fifthly, the crucial aspect to consider is that the bathroom circuit should ideally serve only the bathroom. The exception allows for multiple receptacle outlets within the same bathroom to be on a single 20 amp circuit, but this circuit should not extend to other areas. Sixthly, if a wet bar is located adjacent to a bathroom, it is generally considered a separate area and should have its own dedicated circuit, especially if it includes a receptacle. This ensures that any electrical issues in a wet bar do not affect the bathroom circuit and vice versa. Seventhly, the rationale behind having separate circuits is to enhance safety and minimize the risk of nuisance tripping. If multiple areas are on the same circuit, a ground fault in one area can cause the entire circuit to trip, disrupting power to all connected outlets. Eighthly, by using separate circuits, any issues are isolated to the specific area, reducing inconvenience and enhancing overall safety. Ninthly, in practical terms, this means running a separate 20 amp circuit for the bathroom receptacle outlets and another separate circuit for the wet bar receptacle outlet. This approach provides the greatest level of safety and flexibility. Tenthly, when installing GFCI outlets, it is essential to follow the manufacturer's instructions carefully. Incorrect wiring can render the GFCI protection ineffective, negating its purpose. Understanding these details ensures a safe and compliant electrical installation. Now let's discuss the practical considerations and best practices for installing GFCI outlets in bathrooms and wet bars, focusing on adherence to the National Electrical Code, or NEC, and ensuring optimal safety. Firstly, when planning the electrical layout, identify all locations that require GFCI protection. This includes all receptacle outlets in bathrooms, powder rooms, and any areas with sinks such as wet bars. Secondly, for each of these locations, determine whether a dedicated circuit is necessary or if multiple outlets can be served by a single circuit while still meeting NEC requirements. Thirdly, NEC Section 210.11 C3 mandates at least one 20 amp branch circuit for bathroom receptacle outlets. This circuit should ideally serve only the bathroom, with the exception allowing for multiple outlets within the same bathroom to be on a single 20 amp circuit. Fourthly, if a wet bar is adjacent to the bathroom, it is best practice to provide it with its own dedicated circuit, especially if it includes a receptacle. This ensures that any electrical issues in the wet bar do not affect the bathroom circuit. Fifthly, when running the circuits, use appropriately sized conductors and follow all wiring guidelines outlined in the NEC. For a 20 amp circuit, typically 12 American wire gauge or AUG copper wire is used, but always consult the NEC or a qualified electrician to confirm the correct wire size for your specific installation. Sixthly, when installing the GFCI outlets, carefully follow the manufacturer's instructions. Incorrect wiring can render the GFCI protection ineffective. Ensure that the line and load terminals are correctly wired and that the GFCI outlet is properly grounded. Seventhly, after installation, test each GFCI outlet to verify that it is functioning correctly. The test button on the GFCI outlet should trip the device, cutting off power to the circuit. If the GFCI outlet does not trip when tested, there may be a wiring issue that needs to be addressed. Eighthly, consider the long-term benefits of running separate circuits. While it may initially seem like more work and expense, it provides greater safety, convenience, and potentially increases the value of the property. Ninthly, be aware that the NEC is updated regularly, typically every 3 years. It is crucial to stay informed about the latest changes and requirements to ensure compliance with current standards. Tenthly, always consult with a qualified electrician or local building inspector if you have any questions or concerns about your electrical installation. They can provide valuable guidance and ensure that your installation meets all applicable codes and regulations. The NEC, or National Electrical Code, provides specific guidelines for electrical installations to ensure safety and prevent hazards. Let's delve into the key sections relevant to GFCI outlets, bathroom circuits, and wet bars. Firstly, NEC Section 210.8 covers ground fault circuit interrupter protection for personnel. This section mandates GFCI protection in various locations, including bathrooms, garages, and outdoor areas where electrical receptacles are installed. The specific requirements vary depending on the location and the type of receptacle. Secondly, for bathrooms, NEC Section 210.8. 8.1 requires GFCI protection for all 125 volts, 15 amp and 20 amp receptacles. This includes receptacles installed in dwelling units as well as those in commercial and industrial locations. Thirdly, NEC Section 210.11. C3 addresses bathroom branch circuits. It requires at least one 20 amp branch circuit to supply the bathroom receptacle outlet or outlets. This circuit should have no other outlets, meaning it should serve only the bathroom. Fourthly, an exception to this rule allows a single 20 amp circuit to supply bathroom receptacle outlets and serve only the bathroom of dwelling units. This means that multiple receptacles within the same bathroom can be on a single 20 amp circuit, but the circuit cannot extend to other areas. Fifthly, in the context of a wet bar adjacent to a bathroom, the NEC generally considers the wet bar as a separate area. Therefore, it should ideally have its own dedicated circuit, especially if it includes a receptacle. Sixthly, NEC Section 210.52 outlines receptacle outlet requirements in dwelling unit. This section specifies the spacing and placement of receptacles in various rooms, including kitchens and living areas. Seventhly, although it doesn't specifically address wet bars, it provides guidance on the general requirements for receptacle placement, which can be applied to wet bar areas. Eighthly, NEC Section 210.70 covers the lighting outlets required in dwelling units. While it doesn't directly relate to GFCI protection, it is important to ensure that lighting in bathrooms and wet bars meets the code requirements. Ninthly, understanding these key NEC sections is crucial for ensuring safe and compliant electrical installations. Always consult the latest edition of the NEC and local codes, as interpretations and requirements can vary. Tenthly, it is recommended to consult with a qualified electrician or local building inspector to ensure that your electrical installation meets all applicable codes and regulations. Understanding the National Electrical Code, or NEC, requirements for GFCI outlets and circuit configurations in bathrooms and wet bars involves considering several factors to ensure safety and compliance. Firstly, the NEC mandates GFCI protection for receptacles in damp or wet locations, including bathrooms and areas with sinks such as wet bars. This requirement is outlined in NEC Section 210.8. Secondly, while the NEC permits multiple outlets on a single circuit, specific rules apply to bathroom circuits. NEC Section 210.11. C3 requires at least one 20 amp branch circuit to serve the bathroom receptacle outlet or outlets. This circuit should not serve other outlets outside the bathroom. Thirdly, an exception allows a single 20 amp circuit to supply bathroom receptacle outlets and serve only the bathroom of dwelling units. This means that you can have multiple receptacles within the same bathroom on a single 20 amp circuit, but it cannot serve other areas. Fourthly, when a wet bar is adjacent to a bathroom, it is generally considered a separate area and should have its own dedicated circuit, especially if it includes a receptacle. This ensures that any electrical issues in the wet bar do not affect the bathroom circuit. Fifthly, the primary reason for these requirements is to minimize the risk of electrical shock in areas where water is present. GFCI outlets are designed to detect ground faults and quickly interrupt the power supply, protecting individuals from potential hazards. Sixthly, it is important to note that local codes and interpretations can vary, so consulting with a qualified electrician or local building inspector is always recommended to ensure compliance with all applicable regulations. Seventhly, in practical terms, this means running a separate 20 amp circuit for the bathroom receptacle outlets and another separate circuit for the wet bar receptacle outlet. This approach provides the greatest level of safety and flexibility. Eighthly, when installing GFCI outlets, carefully follow the manufacturer's instructions and ensure that the line and load terminals are correctly wired. Ninthly, after installation, test each GFCI outlet to verify that it is functioning correctly by pressing the test button and confirming that the device trips. Tenthly, keep in mind that the NEC is updated regularly, typically every 3 years, so it is crucial to stay informed about the latest changes and requirements to ensure compliance with current standards. Let's explore some advanced considerations and potential challenges related to GFCI outlets, circuit configurations, and compliance with the National Electrical Code, or NEC, in bathrooms and wet bars. Firstly, one common challenge is dealing with older homes that may not have been wired with GFCI protection in all required locations. Retrofitting GFCI outlets can be complex, especially if the existing wiring is not up to code. Secondly, in some cases, it may be necessary to run new circuits to provide GFCI protection to all required areas, which can be a significant undertaking. This is particularly true if the existing electrical panel is already at capacity. Thirdly, another challenge is dealing with nuisance tripping of GFCI outlets. This can occur due to various factors, such as faulty appliances, wiring issues, or even environmental conditions. Fourthly, troubleshooting nuisance tripping can be time-consuming and may require the expertise of a qualified electrician. It is important to identify the root cause of the tripping rather than simply replacing the GFCI outlet, as this may not solve the underlying problem. Fifthly, when installing GFCI outlets, it is crucial to ensure that they are compatible with the existing wiring. Some older wiring systems may not be compatible with GFCI outlets, which can lead to malfunctioning or even dangerous conditions. Sixthly, in such cases, it may be necessary to upgrade the wiring system to ensure compatibility with GFCI protection. This can be a costly and time-consuming process, but it is essential for ensuring safety. Seventhly, another consideration is the proper grounding of GFCI outlets. GFCI outlets rely on a good ground connection to function properly. If the grounding is inadequate, the GFCI outlet may not trip when a ground fault occurs, defeating its purpose. Eighthly, it is important to inspect the grounding system and ensure that it is properly connected and functioning correctly. This may involve testing the ground connection with a multimeter or other testing equipment. Ninthly, when working with electrical systems, always prioritize safety. Turn off the power to the circuit before working on any electrical components and follow all safety precautions outlined in the NEC. Tenthly, if you are not comfortable working with electrical systems, it is always best to hire a qualified electrician to perform the work. They have the knowledge, skills, and experience to ensure that the installation is done safely and correctly. Now let's cover the implications of using arc fault circuit interrupters, or GFCIs, in conjunction with GFCI outlets in bathrooms and wet bars, and how these technologies work together to enhance electrical safety. Firstly, arc fault circuit interrupters, or GFCIs, are designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that can occur due to damaged wiring, loose connections, or other factors. Secondly, GFCIs work by monitoring the electrical current in a circuit and detecting the unique signatures of arc faults. When an arc fault is detected, the GFCI quickly interrupts the power supply, preventing the arc fault from escalating into a fire. Thirdly, the NEC requires GFCI protection for branch circuits that supply dwelling units, including those that serve bedrooms, living rooms, and other areas where arc faults are likely to occur. Fourthly, while GFCIs are not typically required in bathrooms or wet bars, they can provide an additional layer of protection against electrical fires. Fifthly, when used in conjunction with GFCI outlets, GFCIs can help to protect against both electrical shock and electrical fires. GFCI outlets protect against electrical shock by detecting ground faults, while GFCIs protect against electrical fires by detecting arc faults. Sixthly, it is important to note that GFCIs and GFCI outlets serve different purposes and provide different types of protection. They are not interchangeable and should be used in combination to provide comprehensive electrical safety. Seventhly, when installing GFCIs and GFCI outlets, it is crucial to follow the manufacturer's instructions carefully and ensure that they are compatible with the existing wiring. Eighthly, some older wiring systems may not be compatible with GFCIs or GFCI outlets, which can lead to malfunctioning or even dangerous conditions. Ninthly, in such cases, it may be necessary to upgrade the wiring system to ensure compatibility with these safety devices. Tenthly, always consult with a qualified electrician or local building inspector if you have any questions or concerns about your electrical installation. They can provide valuable guidance and ensure that your installation meets all applicable codes and regulations. A deeper dive into specific scenarios and troubleshooting tips related to GFCI outlets in bathrooms and wet bars, focusing on common issues and how to resolve them effectively. Firstly, one common scenario is a GFCI outlet that trips frequently or intermittently. This can be caused by various factors, such as a faulty appliance, a ground fault in the wiring, or even moisture in the outlet box. Secondly, to troubleshoot this issue, start by unplugging all appliances connected to the GFCI outlet and see if the tripping stops. If the tripping stops, then one of the appliances is likely the culprit. Thirdly, test each appliance individually to identify the faulty one. If the tripping continues even with all appliances unplugged, then there is likely a ground fault in the wiring. Fourthly, inspect the wiring for any signs of damage, such as frayed wires, loose connections, or water damage. If you find any damage, repair it or replace the affected wiring. Fifthly, if the wiring appears to be in good condition, then the GFCI outlet itself may be faulty. Test the GFCI outlet with a GFCI tester to verify that it is functioning correctly. Sixthly, if the GFCI outlet fails the test, then replace it with a new one. When replacing a GFCI outlet, be sure to follow the manufacturer's instructions carefully and ensure that the line and load terminals are correctly wired. Seventhly, another common scenario is a GFCI outlet that will not reset. This can be caused by a ground fault that is preventing the GFCI outlet from resetting. Eighthly, to troubleshoot this issue, start by turning off the power to the circuit and inspecting the wiring for any signs of damage. If you find any damage, repair it or replace the affected wiring. Ninthly, if the wiring appears to be in good condition, then the GFCI outlet itself may be faulty. Replace the GFCI outlet with the new one. Tenthly, if the GFCI outlet still will not reset after replacing it, then there may be a more serious wiring issue that requires the expertise of a qualified electrician.